I developed this project to determine how adjusting seeding rates and nitrogen rates might be advisable when seeding canola late. We're the only site for this project, and I was thankful Adopt funded the project. When seeding late, there are at least two issues to consider: maturity and yield. Obviously, producers would like to hasten maturity because of the late start, so the crop is not frosted prematurely in fall. Roughly, we want plant populations to be between 50 to 120 plants per meter squared. However, when seeding late, it might be better to be at the high end of that recommendation, as this could hasten maturity by 2 to 3 days. As an aside, maintaining adequate soil P also hastens maturity. The other concern with late seeding is reduced yield. Crop insurance data clearly shows that canola yields decline by about 15% as seeding date is delayed from the first week of May to the first week of June. Beyond the first week of June, yields really start to take a nosedive. If yield potential has been reduced, it follows that the crop may require less nitrogen than originally anticipated. So this trial is looking at an early seeding date of May 18th and a later seeding date of June 8th. For each of these seeding dates, 3 nitrogen rates were evaluated at seeding rates of 2 and 4 pounds per acre, which resulted in plant populations of approximately 40 versus 70 plants per meter squared for both seeding dates. So I'm pretty happy with that range. As it turned out, there were many fields this year of canola that were seeded late due to the late start in spring we had this year. So let's see if adjusting seeding rates and nitrogen rates for those fields would have been advisable.
Here are the main effects of seeding date, end fertility, and seeding rate on canola. We looked at emergence, maturity, yield, grain moisture at harvest, and oil content of the grain. Again, the early seeded date was May 18 and the late seeded date was June 8. Levels of end fertility were 70, 140, and 180 pounds of soil plus applied fertilizer N. Finally, the seeding rates for canola were 2 and 4 pounds per acre. Emergence rates were very similar between the early and late seeding dates. So, on average, seeding at 2 pounds per acre resulted in 39.8 plants per meter squared, and 4 pounds produced 70.5 plants per meter squared. Emergence close to 40 plants per meter squared is considered adequate to maintain yield potential, and that was certainly the case in this study, as the yields between seeding rates were nearly identical. Canola is referred to as a plastic plant, and it has the ability to compensate for low plant populations by branching. To illustrate this, Heather is holding up a high seeding rate plant in her left hand versus a low seeding rate plant in her right hand, which has much more branching. In our study, increasing seeding rate hastened maturity for the late seeded canola. The high seeding rate reached 60% seed color change 1.3 days earlier, and at harvest, grain moisture was about 0.5% less. You can see the grain moisture at harvest is quite high, and this was done on purpose, so I could use grain moisture as a relative indicator of crop maturity. I can harvest research plots early because it's pretty easy to dry small sacks of grain on an air table. While these results indicate that the high seeding rate for canola could have been harvested a few days earlier, it would have cost an extra $30 an acre in seed cost and have made little agronomic or operational differences during the 2023 season. Increasing seeding rate provided no yield benefit, and everything would have been ready to harvest by early October. However, if the season had been extended by wet conditions, we might have seen more of an agronomic benefit from the higher seeding rate, particularly if there had been an early frost. As an aside, I'm not recommending seeding rates should be as low as 2 pounds per acre. We had excellent emergence conditions with no flea beetle pressure. So, 2 pounds per acre was able to produce just enough plants to maintain yield potential. In this study, a significant interaction was detected, indicating that the yield response of canola to added nitrogen differed between the early and the late seeded canola. The yield response of canola to added nitrogen was much greater for the early seeded canola, here in blue, compared to the late seeded canola, here in orange. This implies that the late-seeded canola needed less nitrogen. But how much less? Well, this is where it gets tricky, and you'll have to take this with a grain of salt because we're not looking at enough data to really pin down the shape of these curves. If I assume $17 per bushel of canola and $1.30 per pound of nitrogen, then technically no more added nitrogen to the above background level of 70 pounds of nitrogen per acre was required for the late-seeded canola. The response from here was linear, and each additional pound of nitrogen resulted in reduced economic returns. In contrast, the yield response for the early-seeded canola is curvilinear, and the most economic rate is 128 pounds of nitrogen per acre. This is the point at which $1 spent on nitrogen returned $1 worth of canola. This means the difference in the most economic rate of nitrogen between early and late seeded canola could have been at least 58 pounds of nitrogen per acre. Now, I am really not comfortable with suggesting that to producers, that they should reduce their nitrogen rates by 50 pounds of nitrogen per acre when seeding late. You can see here how even a small variation in the position of the data points from the late-seeded canola could have made a difference in the response curve. It could have become more curvilinear and narrowed the difference between the most economic rates for the early and the late-seeded canola. We need more data points to really be comfortable with the response curves and to have more confidence in our interpretation. However, without putting a value on it, I am comfortable saying the late-seeded canola required less nitrogen. A combination of reduced yield potential from seeding late and more time for nitrogen mineralization in spring before seeding may account for the lower nitrogen requirement. It would have been nice if we had quantified this with early and late soil sampling, but oh well, maybe next time. In this study, we looked at the percent oil within the canola grain. These values are based on single samples bulked over 4 reps for each treatment. Thus, the values aren't statistically analyzed. However, there is some evidence to suggest that late seeding or high rates of nitrogen reduce the oil yield of canola. Reducing yield potential by late seeding or applying nitrogen likely favored the production of grain protein over oil. Conclusions. Late-seeded canola likely requires less nitrogen, but determining how much from this study would have required some more data points. However, I have seen some suggestions from the Canola Council that reducing rates by 10 to 15% might be appropriate when seeding into early June. That sounds pretty reasonable to me. Increasing canola emergence from 39.8 to 70.5 plants per meter squared did not increase yield, as expected, but it did hasten maturity by a couple days for the late-seeded canola. This effect might have been even larger in an extended wet season. And then, as a point of curiosity, delaying seeding rate and increasing nitrogen rate decreased oil content of the grain, but this isn't currently a concern for producers to manage at present. I'd like to thank Adopt for supporting this project.